Good morning, good afternoon, or good evening, depending on where you're tuning in from today, and welcome to today's live webinar covering handheld 3D scanning with Dot3D and live interactive virtual meetings with IQ3 Connect. Today's presentation will include live demonstrations of both products. These demonstrations will be truly live, including the fact that this entire broadcast is taking place on a tablet from one of our handheld 3D scanning kits. So given our rehearsals, I think everything should run smoothly, but if anything does go wrong along the way, or if there's a bit of a slow frame rate at any point, please do bear with us as this is truly live from a mobile platform. If you have any questions throughout the presentation and the live demonstration, please submit them through the GoToWebinar platform, and we will answer and address all questions at the end of the presentation. If by chance we run out of time and don't get to your question, do not worry, we will definitely follow up directly via email. So first, I'll quickly introduce myself. I am your host today, Chris Ahern, Marketing, Sales, and Product Manager with DotProduct LLC, checking in from Boston, MA. I'd like to thank Ali and Billy for joining us today as well, and I'll give them a second to introduce themselves before we start the presentation.
Thanks, Chris. My name is Ali Merchant. I'm the co-founder and CEO of IQ3 Connect. We are very pleased to be here with our partner, DotProduct. Thanks.
Thank you.
Good morning. My name is Billy Bush. I'm coming to you from the beautiful Pacific Northwest. I actually don't have a software offering. I'm actually here as a panelist and end user, hopefully capable of sharing with you some of my experiences with both of the softwares we're discussing today.
Thank you both. So first, we'll kick things off with a little bit of background on DotProduct and our Dot3D software offering. Many of you may be joining with some experience with our technology, and some of you may be brand new. So I will, start from scratch, but keep this relatively brief and focus on the live demonstration, which will really show you what we can do live in action, as well as this complete process of bringing it into the IQ3 environment. At our core, we are a handheld 3D scanning company. We deliver software that enables handheld 3D scanning, as well as complete packages that are an out-of-the-box solution to capture 3D data from a tablet or phone-based solution. As you'll see in the next few slides, there are a growing number of options in terms of what type of kit you can utilize to achieve these results. But in any of our situations, any of our products are checking off all the boxes you see here. So we're delivering truly mobile solutions. So you have the full freedom of motion to walk around the scene or object or equipment of interest. Very simple to use technology. So a user-friendly, intuitive interface that's designed to be usable not just by a certified expert within an organization, but to varying degrees, absolutely usable by almost anyone within an organization, something you can pick up and be capturing 3D data with in a matter of seconds. While there's obviously some tips and tricks that can improve the quality of your data, it's really, really intuitive to get to know the technology. All of our solutions are completely handheld, so whether it's a complete kit purchased as a package or whether it's something you assemble yourself as a component of the different pieces you'll see here today, it's all going to be fully handheld, no tripod, no laptop, no long cables required. It's also important to note that we are an inexpensive option in the market, offering packages that range from $1,000 currently to a $6,000 package, all in. So that even that top of the line $6,000 model includes perpetual software and virtually all the hardware you need to start capturing high quality data. We have accurate results with varying options of solutions for different environments, giving you measurable engineering grade data and allowing you to tie down known measurements or known references for large scale scans to really guarantee that accuracy very easily. We also have the very powerful nature of our technology being the real-time results. So you see what you're capturing as you capture it, and you can review it on the fly right away in the field. So at our core, there are 4 components that make up any Dot3D scanning kit. The chief component here, not just because it's our primary technology, but also because it's the one constant between any of these different options, is the Dot3D software. And this is the software you'll be seeing operating live today on a Windows tablet. And then there's 2 more core components that are going to be required for any of these kits to function with your Dot3D software. First being your tablet or your phone that powers everything from the battery life to the live processing in the field. And second being your depth sensing camera. So we support approximately 7 different 3D cameras currently. Each one has a different benefit and in some cases a different drawback. So the idea is that your Dot3D software is a single stop solution and you can plug and play the different cameras depending on your situation. So for certain applications, one camera might have you covered. For others, you might want to have a couple different options at your disposal and you can swap them very easily, even in the same scan. And lastly, we have optional accessories that can be of relevance depending on the scenes that you're scanning. A light kit for capturing dimly lit areas, an extension kit for capturing above ceiling, below ground, etc. Today we will be utilizing the light kit. It's not that dimly lit, but it can give you some nice full color data, even in a slightly dim environment, because it's a nice wide light that points in the exact same direction as the camera itself. So a quick slide with several bullets drilling down on what the core of our Dot3D software delivers. It's producing dimensionally accurate 3D that's instantly reconstructed in the processing power of a tablet or phone. It's providing real-time quality feedback on the quality of every single 3D point that you're capturing, and that's the green and yellow that you see on the screen here in this sample image. It delivers a highly compressed output format, so it makes things really fast and convenient, not only in our software, but in several third-party applications, including IQ3, that have implemented our partnership in order to read that .dp file format directly. Oftentimes for a small room scan, our 3D point cloud scans can be so small they can even be attached to an email. Once you've finished your scan, you can immediately view, measure, crop, annotate, set your coordinate system, compare directly to 3D CAD and more, all directly from within our Dot3D software. And all of that functionality continues to grow. Also important to note that everything you do in our software is completely local and you own the data from start to finish. So there is no internet connection required, no cloud computing required. Everything's happening locally. And of course, if you want to send to the cloud, like we'll be doing today, as soon as you finish your scan, you can, but it's by no means a requirement and something you can tie down for security purposes. You also have the ability to append multiple data sets together on the fly, to link two scans together to capture larger areas or fill in gaps if you realize you missed something after the fact. And we have a variety of advanced targeting workflows, which are very convenient and important to produce the highest accuracy results and link together multiple scans very accurately. So what we'll be focusing on and demonstrating today is our Dot3D Pro version of the software. As you see on the screen here, this is the full feature version that includes virtually all of our 3D capture and 3D editing functionality. This is the professional solution that's deployed on our DPI 10 kits like we'll be showing today, and in most of our professional applications. As far as 3D capture goes, we do have one other version available called Dot3D Scan, and this is a more entry-level version, limited to small area scanning. So single pieces of equipment, bathroom scale room scan can be captured with Scan, but it's entry-level not just in terms of scale, but in terms of functionality. So it doesn't allow for the hard targeting, the scale bar targeting, the linking of multiple data sets together, et cetera. It's more just to get your foot in the door. And those are the two options for the capture side. As far as the view and edit columns you see here, those are two optional accessories that we have to enhance what you're doing with your Pro or your Scan license. They're relatively self-explanatory. The edit version includes everything but scanning. So this is to be installed on your laptop or PC and allows you to offload some of that post-processing, optimization, editing, and export, and take care of that back in a more comfortable, maybe faster processing environment. You don't have to do it all on your tablet in the field, although you can, as you will see today. And lastly, we have a view license, which is totally free of charge and allows you to easily share those compressed DP files with third parties for completely free viewing of all your 3D data, measurements, annotations, etc. So component one was the software that's just covered. That applies to any of the applications in the hardware side, of which there are a growing number. In terms of tablets, we are fully supported on both Android and Windows 10 platforms. So this could be a Microsoft Surface Pro tablet, a rugged tablet to be deployed on a Windows or Android platform. Or in the case of the DPI 10 in bold here, there are two particular tablets that we support. The Microsoft Surface Go or Surface Go 2 is what we're operating on currently, and the Samsung Galaxy Tab S6. And this is just a constraint of the DPI 10, which is our most ergonomic design, complete handheld 3D scanning kit, and those two preferred models of tablet will slide directly into the device. We really like the Surface Go 2 because of the form factor, the processing power, and the price point. It's also important to note that we not only support tablets, but we also support phones, especially with these new cameras coming from Intel Realsense that are small, lightweight, and affordable. You can be firing up Dot3D on an Android phone and attaching a Realsense camera directly to the back of it. We support, there's so many Android phones out there, we can't possibly list them all, but we support a wide variety of Android phones, in particular the flagship models from the leading brands today, including Samsung, Google, and more. Lastly, we need to touch base on the 3D cameras themselves. So our DPI-10 and DPI-10SR kit are two options, primarily focused around indoor scanning. As you see on the screen here, that's the one that we're talking about that's more of a complete hardware kit. Tablet slides into the back and the camera is actually built into the housing. These excel in terms of indoor room scale scanning. The DPI-10 has a range of 2 to 12 feet, so that's the more versatile option for larger area room scanning. And the DPI-10SR has a 1 to 6 foot range, so it can't see nearly as far, but it lets you get in closer. So in the crime scene example we're talking about today, the DPI-10 standard model is going to be your most versatile option for scanning an entire scene. If you're trying to go get more detail on a particular piece of evidence or a body, for example, the DPI-10SR is going to get you more discrete detail in that situation. Next, we have our growing list of supported cameras from Intel Realsense. These are some really exciting, powerful new cameras that come at a low price point and a small form factor and can be utilized either as an accessory to the DPI-10 or oftentimes as a standalone camera in conjunction with your own tablet or phone. The two latest models that came out within the last 6 months or so are the Intel Realsense LiDAR camera L515, that's the round puck-shaped one you see here, and the depth camera D455. These each offer unique benefits. The D455 is our current recommendation for those looking to go scan outdoors in bright sunlight. The DPI-10 kit, for example, can be utilized outdoors in shade, early morning, evening, but if there's going to be any direct sunlight, you're out of luck. So you pop on that Realsense D455 and you can go capture high quality data even in a bright sunny environment. The L515, on the other hand, is very much an indoor-only camera, even more so than your DPI cameras. However, it offers extended range and very tight inherent accuracy given the LiDAR technology. So if you are in a fully indoor environment, it can see up to 20 feet at any point in time. And then we also have on the top right here a couple more of the D400 series of Realsense cameras, which we do fully support. So if you have a D415 or a D435, those are supported, although not normally recommended now that these new cameras have come out. The one benefit of the D415 over the D455 is that it offers some excellent colors even in bright sunlight. There's sometimes a bit of tinting with the D455 in bright sunlight, although they both work very well in that situation. So 400 series are your outdoor capable options. So here's what we're looking at today. This is the DPI-10 kit with the DPI Lite kit conveniently attached right to the top, and a Microsoft Surface Go 2 tablet slid directly into the back of the device. I'm actually talking to you right now through the exact device that you see on your screen, and we'll switch over to a live screen broadcast so you can see it in action shortly. With that, I'm going to pass it off to Billy for a few comments on his use of this technology and appreciation for its applications, particular to the crime scene mapping world.
Thank you, Chris. Again, my name is Billy Bush, and I am an end user of the software here. And my history and my background has been about the last 10 years in public safety, specifically with crime scene reconstruction. What brought us to DotProduct was ultimately it was the most cost-effective entry into reality capture where we could tie it back to real-world controls. The auto registration of April tags within the software allowed us to give quick, easy scale to everything that we were capturing into the field. And it came in at a price point that was easy to test and even easier to expand to a variety of investigators spread across a relatively large geography. Additionally, it works across a spectrum of devices. So every device comes with limitations. As Chris has already highlighted, in the Realsense line, there are cameras that work incredibly well on exteriors, but every device has shortcomings where other devices can excel. It works with all of those devices. So it's easy and fast to switch between those sensors, even within a single scan. So we can get a certain amount of data with one, and as we transition, say, from an exterior to an interior, we can just swap sensors inside that scan and continue our data capture to complete our scene. Also, the software has remained relevant. I've been utilizing the software for about the last 2.5 years. And as the sensors have evolved, they've been adopted into the software. So I don't need to learn new software. I don't need to buy new software. I simply gain access to the new hardware and pick right back up with the same workflow that I've become accustomed to. What I found that was so useful, especially trying to distribute it across the country or beyond, is introducing it to new users is incredibly easy. Real-time feedback and the intuitive workflow make even brand new introduced to the software today individuals capable of that reality capture almost immediately. Also, the compact file size makes it accessible to our new users and remains relevant as we've grown and established ourselves as programs across the country. Beyond that, introducing that software and its outputs into IQ3, what I've found that especially in the COVID age, we've all gotten far too accustomed to having to deal with interacting from a distance and working online. As we expand our geography and we cross time zones or countries, their ability to provide us with asynchronous collaboration gives us a bridge to connect that geography. That independent simultaneous access in that shared environment, it helps us expedite identification of flaws or missed areas in our data sets. We can pick those up, identify them readily, and the multiple perspectives in that space at once gives us the ability to streamline our ability to output our final product to the end user. That VR experience, while that was one of the first times that we had been introduced to virtual reality, it gave us a scale and allowed us to set context with our scenes on a way that a flat screen really never could. Our ability to shift that perspective was incredibly valuable. Beyond that, especially working in the public sector, data security is a huge concern. And the bottom line is that this isn't a cloud-based software. While it is, it can also be scaled to make sure that we can meet our data security needs. So that software can be installed in-house on our servers behind all of our IT security safety nets so that we can maintain the type of security that we are required as we move forward with our data sets and processing. Chris?
Awesome. Thank you, Billy. And I will slide over to the next slide and pass it over to Ali.
Thanks, Chris. So IQ3 is a web collaboration platform. It allows anyone to work with their 3D content, as Billy mentioned, from anywhere, pretty much anywhere in the world. It works with different types of 3D content, and it provides a very simple way to communicate and collaborate either from your desktop in a 3D spatial environment and also with VR and AR. There's no development required. It's a very simple out of the box, just sign up and bring your data and start using the software. So that makes it very affordable and you don't have to be an expert. We provide it as a SaaS solution, so that makes it very affordable and easy. You can also install it on your private cloud, very securely behind your intranet. It comes with an integrated self-service dashboard. So we're not just talking about a standalone VR system, but something that provides a complete end-to-end solution where you can upload and manage your content, manage your users, create training and other types of workflows, as well as integrated into your business processes. From this integrated dashboard, you can launch secure workspaces, and these workspaces allow you to bring in your data, invite your colleagues, team members, anyone into this multi-user spatial environment where you can do design reviews, train, or just simply learn or use it for education. And these workspaces are inherently collaborative, so that's really part of our DNA. And it's not an add-on; it's built in. So everything you do is 100% collaborative, real time, and interactive. The nice thing about IQ3 is you don't need to install anything. It works directly from a browser, so you can use it with a browser and simply send someone a link, and they can join your IQ3 workspace. And these workspaces come in different flavors, so you can have an instant meeting where you can just fire it up and invite people with your 3D content, or you can schedule it, or you can use it in an asynchronous manner where you're running these 3D workspaces over longer periods of time. Just think of it like kind of like a Teams or a Slack channel where people can come in, collaborate from different time zones or different locations, and all of your information stays persistent. As Billy said, it's very seamless to use it with any of the supported VR systems like Oculus Rift, Oculus Quest, HTC Vive, or the Windows mixed reality headsets. And you can also run it in a hybrid environment where some people can be in VR, or some people can be on a tablet, or simply on their desktop, what we call the desktop VR mode. And you can also very easily bring in both scans, like a DP scan, which you will see in the demonstration, as well as 3D CAD data and other types of content that we'll show you in the demo. So that can provide a very rich 3D environment for different types of workflows. Some of the applications of IQ3 are, for example, team reviews, where you can use it for design review collaboration or manufacturing simulations, as well as remote training and support. Think of it like almost like a digital classroom where you can administer product related training, or just learn about what a product might look like and how it might function. You can also embed it in learning platforms for educational purposes. You can try IQ3 Connect for yourself. We have a live VR collaboration workshop on April 21st. Please come to our website and register for it. You will be able to experience, and so you can register live on our website. You can also at any time sign up to try IQ3 free of cost. You can sign up on our website. We have a lot of resources, pricing, and other information available on how you can start using IQ3 instantly. Thank you, Chris.
Thank you, Ali. It is that time. So now that we've covered the basics of everything we're going to be showing today, I've walked over to our simulated crime scene, and you've all walked with me on this tablet that we're broadcasting from on the DPI-10. And I'm going to switch from PowerPoint over to our Dot3D software. So now you all see what the 3D camera sees. You'll notice that I have this April tag cube that I'm going to use as my start and finish point. I also have some very convenient magnetic 3D printed April tags from Billy at Air Insight Consulting that work really well for these situations, also for vehicle crash scenes due to the magnetic capabilities of them. These tags are going to be where I start and finish my scan and just loop over periodically throughout my scan process. As to why I'm using the DPI-10 in particular today, of all the options available, I'm indoors and I'm doing a large scale room to a degree, so that would make this a better fit for the DPI-10 versus the DPI-10 SR. And there is some window light coming through. So in that way, the DPI cameras do still perform superior to the L515, although it's not a lot of light, and that camera would probably do pretty well here as well. But with that being said, let's start scanning. So I press this button on the right, and I'm immediately capturing a color 3D point cloud data set of everything I pointed at. You see those tags turn orange automatically as they're recognized by the software. And I just want to move in a natural pace throughout the scene. We have a few different buttons at our disposal while scanning. The bottom left button is called our plane picking constraint, or parallel planes option. This is something that you pretty much would only use in an indoor environment where you trust the floor and walls as being flat, level, and parallel perpendicular to each other. And it's a nice feature that just automatically gets applied during the optimization if you recognize any level surfaces in your scan. So you'll notice me press that button periodically as I'm pointing at a flat wall or a flat floor. And what it'll do is it'll recognize that if I flag that same floor at 2 different points of my scan, maybe not necessarily with a clean overlap in my process of walking between those areas, it'll make sure that those are locked in as parallel to each other. Same would go for 2 parallel walls, etc. You can see the holes in your data in real time. So if I want to get some more detail around the feet here, I can go in and just bend over and fill it in. As mentioned earlier, if I was trying to get the most detail on the body in particular, then the DPI-10S RAW camera might be a better fit. And you can use both hand in hand, as Billy mentioned earlier. If I wanted to go outside and get some more data of the trajectory into this room from outdoors, that's when I would use a lot of Intel Realsense D455 or D415 depth cameras. The green and yellow is an overall quality report based on angle, distance, time on target, reflectivity, etc. So you just want to keep that in mind, and whatever's most important, paint nice and green. A good practice is to capture your entire scene, as I've started to do here, in lighter green or yellow. And then once you've done that, move in to get more detail in darker green of the particularly important areas, such as this piece of evidence. Now, if I really want to get some more detail on this, I can also use our HD photo capture capability. So if I press and hold on the bottom right, I'm capturing a high resolution 2D image from my tablet camera of that particularly important piece of evidence. In other industries, it could be an area that was damaged and needs to be repaired. It could be something you just need more legibility on. And that image is going to be saved into our 3D scan file with a viewpoint and perspective of where it was taken from. So in a normal situation, you might have a stack of photographs, but not really have a good understanding of where you were actually standing. So this will tell the whole story in 3D while also giving you the benefit of your traditional photographs. If you see the left side of my screen, you'll notice there's a green bar. That is an indicator of my maximum scene size and my progression toward that mark. So you'll notice that this entire room that we're scanning here today is no more than a tenth of what you can be doing in a single scan. If I move a little too quickly or trip like I just did there, it'll automatically cut out and prevent you from capturing any bad data. So this is a really important feature. And you just move back to where you just were, and 9 times out of 10, it'll find itself automatically. If it struggles at all, you can also choose a particular frame to reposition yourself in. And this is if you move too quickly, if you approach a reflective surface like I just did, or if you get too close or too far away. Anytime it doesn't necessarily trust the data that's being captured, it's not going to allow you to get that data, but it will let you continue from where you left off very quickly and easily. Same would go for if somebody walks through your scene, for example. Now, while shiny surfaces or dark blacks can be challenging with almost any 3D capture device, with the DPI-10 and DPI-10SR, they do a really good job at capturing them. And our software is an important part of this because you can see that it's struggling with a particular area, and you just need to get in a little closer, a little bit of a different angle or distance. And almost always, unless it's a fully polished mirror, it will fill in nicely. So with that, I'm going to finish up our quick sample scan here. Always make sure to start and finish at the same area called closing the loop. And ideally, you want to close your loop on some April tags like we're doing now. Get some more data on this wall and then finish up. One more thing before I finish that I forgot to mention earlier, we touched base on the bottom 2 buttons. We also have this crosshair icon. So this is a very unique capability that allows us to annotate while scanning. So if I want to add an annotation to this crowbar as a piece of evidence, I press that crosshair icon and then release. And that's going to add a pre-marked annotation for me. And I can also add a photograph to that as well. Now let's finish up our scan by pressing the same button we started with, and it'll immediately crunch away on the hard drive and create our preview, our unoptimized data set. And this is a chance for you to make sure you got everything you need. It's not necessarily representative of the final result or the quality quite yet. So it processes locally in a matter of seconds, and you can take a look at your scan. So any fuzziness, mismatching, overlap, anything like that is completely normal at this stage. But this is a chance for you to just take a look and make sure you didn't miss anything. If you did, you can seamlessly add it back in on the fly using the scan append option. But to save time today and to move forward with the IQ3 workflow, we're going to assume we're happy with everything we've captured so far and move on to the optimization step. So you'll see here that there are a few constraints automatically being applied. I'm going to go ahead and get that process started. You'll also notice that it's warning me now because I'm running GoToMeeting on this tablet and there's a lot going on. It's saying, hey, you might want to consider closing these applications before you optimize or before you start scanning. It could slow things down. So with that being said, let's go ahead and get it started since it does optimize slower than normal when we have this memory intensive GoToWebinar running in the background. What's happening here during the optimization is it's leveling the colors throughout the scene, it's tightening the frame-to-frame alignment, it's cleaning up any noise or stray points that are recognized in the data, it's applying those April tag targets that were utilized. In this case, I just used the most basic functionality of the April tag. So you notice that I started at a few April tags, I finished back at them. Also periodically throughout my scan, whenever I had an opportunity to, I looped back over an April tag. Essentially, anytime you hit the same unique tag more than once, the software automatically recognizes I've been to the exact center point of target number 7 at the beginning and the end of my scan. If in the unoptimized data, maybe that target wasn't quite perfectly lined up, maybe it was a little bit off, at least in the unoptimized scan, that April tag recognition will guarantee that those are going to be exactly aligned. And if you can understand that, you realize that'll make every single point in your cloud a little bit more accurate, totally automatically and totally behind the scenes. Some other functionality you could have implemented before optimizing using April tags is to reference a known measurement. So if I really wanted to tie down the accuracy of this scan, especially if it was a larger room, I could put an April tag on each wall, take a tape measure or a laser measurement tool and just measure the point-to-point distance between those two tags really quickly. And before I optimize, I just tell the software the distance between target 7 and target 20 is 12.7 feet, and that'll automatically ensure that your data is scaled to those precise measurements. The best practice for that is to take a quick length, width, and height measurement, and that will really, really tie down your data. All of these workflows, even that basic April tag workflow, are totally optional. You don't need any targets at all to create a data set like we just did, but they're very easy ways to get that added confidence and accuracy, especially for larger area scans. Those parallel plane constraints, so anytime we flag the level surface as being parallel to itself or to another plane, those are automatically being accounted for during this optimization. And it's just cleaning everything up and preparing your data set into its more final form for further manipulation and export to different file formats. It's also very important to note that everything that happens from this point forward, including the optimization that's going on right now, doesn't have to be happening on your tablet by any means. As soon as that initial data set, the unoptimized data, was shown to us, we know that our file has already been auto-saved in a compressed backed up format onto the hard drive. So every single scan you ever take is automatically auto-saved and timestamped. So you always have that backup to revert back to at any point in time. Then if you wanted to, for example, save time, battery life in the field, move on to another scan, another area of the scene needs to be captured. As soon as that autosave has been captured, you can go ahead and continue scanning, knowing that you have that backup ready. And you can be doing this optimization step on the tablet later, or more likely you'd be doing it on your laptop or your PC at a later point using a Dot3D edit license, which is available for as low as $12 a month and allows you to do everything except scanning. Today we're demonstrating the mobility of the solution and the ability to do it on the fly and see what you have in a matter of minutes in the field. But practically in many situations, you would just do your scanning in the field and do your post-processing in Dot3D edit, and you'll always have both options. So this optimization step, depending on the size of your scan, typically takes between for a real small scan, 30 seconds to maybe 3 or 4 minutes on average. If you did max out your scene size to that bar that we saw earlier and you captured a very, very large scan of 160 million points, multiple rooms, then you should be prepared for long optimization times to the 15, 20-minute mark, at least on the tablet. But if bring this over onto a faster laptop or desktop PC, that'll speed things up as well. In this case, it's already been, I don't know, a minute or two here, and I expect that it'll jump to the end and finish up in no more than 30 seconds. Now, once this finishes up, we're going to take a quick look at our scan. You'll see everything cleaned up nicely. The colors will be brightened, and any sort of misalignment or fuzziness will be really crispened up in our data. We're going to do a few steps here just to demonstrate a little bit of functionality in Dot3D to clean up our data, reference our coordinate system, etc. And then we will switch over to upload it to the IQ3 environment.
And Chris, as you had mentioned, that autosave is a huge feature that has saved me on more than one occasion in the past. You get in and realize that you possibly had made a crop that you didn't intend on. Having that backup data has been invaluable.
Excellent, thanks, Billy. And similar to that, I know another feature you mentioned being particularly valuable is that append capability. So now's our chance to look at our final result. If we realized either before or after optimization that we missed something, that we didn't get the data we needed behind this light pole, for example, and that's important to us. You can go back and add that in at any point. It doesn't have to be right away. It could be the next day, as long as there's an area of your scan that hasn't changed. You relocalize to that point and you continue. That's also how you can utilize multiple cameras, for example. So if I wanted to switch and do an outdoor scanning system, I can append directly using that capability. So now we have a view of our optimized data set. You'll notice everything looks a lot cleaner, crisper. You can zoom in here to take a look at the level of detail and density, about 2 millimeter point spacing typically with the DPI 10, and a higher density on areas that you turn darker green. Before we go ahead and export this data, we need to do a couple things here. So we'll go to our Edit tab and set our coordinate system. So you'll notice that Dot3D automatically guesses at a good point for a origin. The origin point is in the corner of our room. And let's say for this example that we wanted it to be over in this corner instead. I will do Edit. Let me just clear out my GoToWebinar and pick origin. So then I press and hold anywhere on my screen, I get this zoom window. Then I release when I'm happy with where that origin point is going to be. It could be a 0, 0, 0 as in this case, or it could be any XYZ coordinate. And I press and hold on the floor to set my Z-axis straight up and hold on the wall to set my X-axis straight out. So now that's our origin point. Everything in our scan is now referenced to that point. So you can measure from any point to point within this cloud. If I wanted to measure a height of this table, for example, and I measure the distance from the floor to the tabletop, it'll give me not only my point-to-point measurement of 46.7 inches, but also my change in X, change in Y, and change in Z. So that height from floor to surface is 37.7 inches based on the coordinate system that was just set. You'll notice that we now have a 1 next to our measurement tab. That's because we made one annotation. We also have a 1 next to our annotation tab. That's because we made an annotation while we were scanning. So there's an annotation here next to the piece of evidence that is our crowbar. And if we hit complete unfinished, it'll bring up the image. Let's indicate that we want this to be a photo annotation to maintain that image throughout. Press confirm. We'll title that crowbar. Okay. And complete. And that's now filled in the name and the image that's tied to that annotation. If you want to add more annotations to your data other than during the scan time, it's very, very easy. You press and hold and release. And we'll call this evidence 2. And that's all being built in and saved directly into our file format. Lastly, if we go to our View tab, we can see our HD photos that were captured earlier. So you see these icons on the screen that are showing where I was standing and pointing when each of these images was taken. If I tap there, it brings me there in 3D, but if I hold on it, it'll bring up the high resolution 2D imagery of that particularly important area of interest, which can really be helpful with stuff like this. You can also attach your own images. So if you have, very high resolution crime scene photos that were not captured from the device itself, you can attach those as annotations as well. The last thing we want to do is quickly crop our data set. This is important for almost any scan, whether you're linking multiple scans together, just trying to clean it up for better presentation purposes, or if you want a smaller file size. It's important to get rid of all that extra data that you don't care about. So we can do a direct top-down view, select just the part of the scene that's of most importance to us. Invert, it's what's in red that we'll be getting rid of. Do view, vantage point front, and chop off any extra ceiling data that we don't care about. And then once we're happy with that, we press crop. Apologize if I'm going a little quick through all of this, but we want to make sure we get over to the second half of this as quickly as possible. So now that we've cropped, cleaned up, and set our coordinate system, and we want to move into the IQ3 environment, we're going to go to File, Save As. And we have a sample scan we did earlier today and pre-prepared to save time called IQ3 Webinar 1. And I'm going to do this one called IQ3 Webinar 2. And in this way, as soon as I finish here, Ali has a scan ready to go. It only takes a matter of minutes for this to process into the IQ3 system, but we're running out of those minutes. So we'll speed things along here and take a look at potentially both data sets. So now that that file has been saved, I'm going to open up my browser-based IQ3 and just press the upload button. Then I want to select. There's IQ3 Webinar 2 and start upload. So that is now uploading. You'll see it'll be up there in a matter of seconds, and then I will convert it to a VR model. Now if I go to IQ3 Webinar 2, I will select Create VR Model, and that is now in process. You actually receive an email immediately as soon as it's ready. And with that, I will switch over to Ali again, who will give us a demonstration better than I can of his product and of all the best benefits of our data within the IQ3 system.
Thank you, Chris.
Thank you.
Thanks, Chris. So as Chris uploaded the data into our SaaS platform, I can access the same thing here. And whatever I will be showing you today, you will be able to do yourself with your DP scans if you sign up for a free trial. So please head to our website after the webinar if you're interested in a free trial. So I'm going to log in to the dashboard. And once I do that, I can see that I can see the DP scan that Chris has launched. Now I cannot access this unless he shares it with me. So what I will do is go to the scan that we did earlier today. And in the dashboard, you can see that we have all of the 3D content, the VR ready models, additional assets like images, videos that you may want to bring into your 3D space, meeting or workspace management, user management, and configuration that you can integrate into your enterprise business processes. So with that, I'm going to head over to the VR ready models. And as you can see, I have a bunch of scans in my folder here. And I can click on one or more scans to then launch my 3D workspace. So in this case, I'm going to pick the IQ3 Webinar 1. And I can schedule a meeting or I can create a quick meeting. And I'll make it public so Chris and Billy can join my meeting from wherever they are remotely. So with that, I can just jump into a 3D meeting space. And as you can see, unlike other applications, this is a truly 3D spatial environment where I can move around. And so I see Billy has joined my meeting, and he can move around, and I can see his avatar, so I can see spatially where he is. And what we're doing now is using it in the desktop VR mode, which means that you don't really require a VR or an AR headset. You can simply use it from your tablet or from your laptop or PC. And here I have the two files that I selected to start my into my meeting space. So I'm just going to click on this, and what this does is it loads up the scan. So now both Billy and I can step into the scan or work collaboratively inside this scan space. So I'm going to give you a bird's eye view of the scan. Now in IQ3 we also have a very detailed 2D menu which allows you to manage the meeting. So follow presenter, I can see that in this meeting there are just two of us, but you can have many more participants in the meeting, built-in audio, chat, and other tools, productivity tools that you can use for collaborative workflows. We also have an enter VR button. So I have my Oculus plugged in here. So in one click, I can seamlessly switch from the desktop VR mode to a fully 3D VR mode. So Billy, please feel free to point out if there's anything that you'd like to see specifically that is meaningful for your workflow. So I can see that Chris, who's DotProduct 3D, has also joined my meeting. So now there are three of us in this meeting space. So I can look around, I can activate my pointer, so I can show Billy, for example, this little green dot. And Billy, could you turn on your pointer so we can kind of point to the same thing? So now simply with my mouse, I can start collaborating with Billy. And I can do things like a measurement in the scan. So with 2 clicks, I can take any measurement, and I can also look at the details of that measurement. So who's placed that measurement, and this is persistent. So I can leave this and come back later and still look at all the measurements or annotations that we made in the space. So I can turn off the measurement and let's say put in an annotation here that says, and when I click on it, it gives me a keyboard, and I can say evidence 19 needs inspection. So I can leave that note for Billy, and then he can come back and take a look at it, or we can sort of collaborate simultaneously from his location in wherever he is, and I'm here in Boston. With that, and we have other capabilities as well, such as viewpoints, which allow you to save a complete walkthrough, creating tags, and we also have a very powerful clipping capability that I can show you here, where you can actually really clip the point cloud and focus in on exactly what you may be interested in. So I'm actually clipping the point cloud dynamically, and everybody in the meeting can dynamically see the clip plane. So you can remove excessive clutter and really focus in on what you're interested in. So as you can see, Billy is down in the meeting space, and I'm just going to step back and take a bird's eye view of the scan. And I can also see that Chris is also in this meeting space. Now, very quickly, I'm also going to just click on this enter VR button here and step right into and put on my Oculus what I am seeing in VR. So I can seamlessly go from the 2D mode into a VR mode. And what this shows me is the VR menu that I have on my hands, and I can step right into this 3D workspace in VR, and that shows us very quickly how we can go from a 2D desktop mode and collaborate in a hybrid manner in a completely 3D in a 3D VR environment.
Thank you, Ali. And it's worth noting that while we had a previously captured scan just from this morning to save time, within 2 minutes, I think, of us passing the presenter over to Ali, the live scan from today was ready. So if you wanted to pull that scan up quickly, Ali, just to close the loop on that, that would work. And then Billy also has a live meeting of his own running in IQ3 right now that involves a real crime scene data set that we can show you before we close off and start taking questions here as well.
Sure. So Chris, you'll have to create that meeting. So with your so I see that
Yes.
Chris has created a meeting. So all I have to do is, now since this is a public meeting, all I have to do is just join this meeting. So in fact, we can have multiple workspaces running simultaneously that one can enter into. So this is the actual scan that Chris captured just a few minutes ago. And I can simply walk into the scan, and now I can look at the exact 3D scan that was taken just a few minutes ago.
And
Okay.
this meeting was actually launched from the tablet that I'm still on. Everything I'm doing today is from the tablet. So I just hit that start public meeting button, and now others in remote locations are able to walk through the same scene that I just walked through with my DPI-10.
And finally, I think the bonus is we look at an actual crime scene that Billy has imported into his quick meeting. So I'm going to now switch back to the dashboard and click on join meeting so that I can join Billy's meeting. And we can actually see a real crime scene. And what we see here are multiple rooms, kind of a bird's eye view of multiple rooms in a scan that was taken with a DP scanner. And we can see how easy it is to bring in the scan data and have multiple meetings with multiple people in VR or in a hybrid desktop environment.
And in this case, the scan device was a DT Research highly ruggedized Windows tablet that actually has an Intel Realsense D415 daylight capable camera built directly into the rugged tablet. So it doesn't get any more convenient than that. And that's how you see that there's outdoor scanning of the front yard and then directly into the entire crime scene space with multiple rooms all captured using that D415 camera. So thank you both. I think this is, yeah, go ahead, Billy.
I'm sorry. In this scene in particular, Chris, I just wanted to highlight a couple of things, both on DotProduct's capabilities and IQ3's. You can see how I had kind of cropped up and captured some sections of the ceiling. So that dynamic clip plane that Ali had demonstrated previously would serve incredibly well to drop down to make sure that we are taking it out to really give ourselves a better idea of the layout of the space itself. Also, as you had highlighted, the April tags on the exterior prior to moving inside, the auto registration and capturing those April tags with a GNSS rover allowed me to take the data set and move it into a real world system where it can be integrated with other data, such as data captured with a UAS or terrestrial scanning device to supplement or to complement each individual set's values.
Thank you, Billy. And I think that top-down view with all these scans does an excellent way of showing how this is an incredible way to show a scene not only like you're there, but even more than you're there in a way that you wouldn't even necessarily be able to fully visualize and comprehend it live. And it's all done in a matter of minutes or seconds here in today's webinar. So as we're running out of time here, I think we should switch over to some of the questions that have been submitted throughout the presentation. So I'll start chronologically and move through as many of these as we can. We'll probably go over another 5 or 10 minutes. So feel free to drop if you need to, and we'll answer as many questions as we can and most definitely follow up via email as well. So first question we see here is, are PrimeSense cameras supported by Android? So most definitely. That actually, the PrimeSense cameras were the first cameras we supported when we got started as a company, and Android was actually the first platform we supported. So the answer is yes. How much discrete detail can the DPI-10 SR attain points per square inch? Well, I don't have a points per square inch answer ready for you. We can get you that, but I can tell you that especially with the DPI-10 SR, you're looking at about 1 to 2 millimeters between point. I tried the Android trial and I couldn't make the S10 Plus recognize the camera and it never worked. So first question would be which camera in particular you're trying to use. Second note here is, Android can be tough because there's so many different models, all with different specs. Even each phone has so many different types, as you may know. But we have found that the processing specs for the Galaxy phones are different for the North American model versus the European and other countries, and that has some degree of an effect. I would recommend starting a new trial with the very latest version of Dot3D 4.0.3. We have made some tweaks to address this particular issue, and I think you should be operational with the latest version. Next question here. Is this the same system I saw in a recent video by the French National Police? So excellent customers at the French National Police, and we were glad to see just this week that they shared some video of a very similar type sample crime scene situation like we did today. The system in that case was the Intel Realsense D455, so the very newest Intel Realsense camera. Also, in that case, operating on an Android tablet, the Samsung Galaxy S7. So same software, different hardware. Can you add coordinates to April tags before optimization? Absolutely. So this is the number one best practice if you have that ability. So if you have the knowledge of the coordinates of your April tags, you're not only going to get the most accurate data, but you're also going to get a rotation and translation into a larger coordinate system. So if you can specify the XYZ coordinates of 3 or more April tags before optimization, you are going to get some excellent data that way. So how do you create the tags? So first off, they're available for download directly from our website, can be printed on any array of materials as you see fit. They are also available for purchase from Billy's Air Insight Consulting in the form that we use today, which is the hard plastic 3D printed magnetized tag, which is incredibly convenient. And that's how we pop them right on the fridge and the metal tables in the scan today. Ali, we have someone who's looking for an idea of the pricing or the options that they'd be looking at for the IQ3 Connect.
Yes, so we have several SaaS offerings that are listed on our website. There's a Pro and there's a Team, and then there is an Enterprise as well. So please visit our website and feel free to contact us. The pricing is available there.
Next question here. Are there problems with scanning geometry captures of curved surfaces? In short, no. The more variance, the more geometry, the better. The worst case scenario is, completely empty, completely textureless, flat white wall. That's where you struggle. But if there's anything going on, curvature, even just texture, so color changes, all of that is going to assist you as you move through your scene. So the good news is it's very uncommon that you want to 3D scan a giant empty white wall, because a tape measure would probably have you covered in that scenario. So the more that's going on, the better. And that's an indicator while you're scanning. I didn't mention today, but around that start and stop button, there's a bar that fills up that tells you how well the device is tracking. So it's an indicator that helps you, say, start at the corner of a room and then back up to fill in those harder areas, and pay attention to that scene fitness bar while you're scanning. What is the maximum number of points that can be loaded into the IQ3D VR? I don't know if you have a particular answer for that, Ali, or if you have an idea of the scale.
Yeah, so we can go to hundreds of millions of points and even push it beyond that. So we have scans of entire facilities or city blocks. So we can handle a lot of data. It also depends on the virtual machine that's used on the hosting. And so we do have high performance options if those are needed to support larger point cloud files. But yes, I think that we can support fairly large scans.
Excellent. And question here. For the scanning side, what measurement tolerances are you getting for, say, construction? So The important term here is attainable measurement tolerances, because given the nature of handheld technology, you know, you can't just go run down a giant hallway with no targets, 1,000 meters and say it's the same as if you scan a room to high accurate detail. But in general, the answer is 2 to 5 millimeters, and that's what the DPI-10, DPI-10SR, and the Intel Realsense L515. An attainable measurement accuracy for room scale scanning, and that can be ensured across larger area scans or multi-room scans by referencing some known measurements or some known coordinates. So it can be as simple as that point-to-point measurement, as mentioned earlier, on the length, width, and height of a room. Or it can be if you have survey points or even drone data, as Billy mentioned earlier, to tie into. So a question here is there a way to turn off color? Not in our software, currently at least. One interesting fact that I can mention somewhat similar to that question is that the Intel Realsense LiDAR camera L515 is our first camera that actually can capture even in pitch black without a light, without color. And so that's given the nature of that it is a truly LiDAR camera that allows for that. So even without a light, if you want to stick the L515 down a manhole or go get some data in pitch black, you're going to see through the tablet almost like an infrared, and even the April tags will work in pitch black with that camera. But the color is a crucial important about a part of the data that we create. Every single point in the cloud is an XYZ RGB, so we don't currently have a way to turn that off. Secondary question here on the April tags: do you print them on paper and tape them to the wall? That is the most traditional way to use them. Yes, that's absolutely easy to do. Question here for both of us, Ali, is can the annotations and HD photos captured in Dot3D be exported to IQ3? So we have that capability in both packages today, but the sync is not there. But correct me if I'm wrong, I think we will be working to have that coming soon. It's definitely doable, and it's on our pipeline.
Yes, that is correct. It's on our roadmap, and what that'll enable is any metadata like the annotations or images will be imported and automatically processed, so that when you bring your scan into IQ3, you will see the images and annotations and exactly where they were placed in DotProduct. Today, you can import images and place them into IQ3 and save them as a scene. So that scene is now something that you can open up in one click, and it'll show you the images and so on that could come from DotProduct. So it involves a little bit of manual effort, but it's doable even today.
Awesome, thank you. And last question here for me is, can you give some idea of the data scan size that is possible with DotProduct software, i.e. can you scan the interior of a cathedral or a stadium? The short answer to that second part is no. We are primarily small to medium sized scanning. However, there are definitely some caveats to that. The first one being that we work very well hand in hand with more traditional tripod laser scanning solutions. So you can contract out a tripod scanner if you're trying to scan a cathedral or a stadium, and if you have particular areas that you want to go get more detail on that you need to fill in after that, more coarse large scale scan has been captured, those data sets can be synced together, and your DPI is kind of your more hands-on kit to go get the close range detail. As to the idea of scan size possible with the DotProduct software, it really varies depending on what your goal is. So if you're trying to get ultra dense detail of every single piece of furniture in a indoor environment, for example, you're going to run out of space a lot sooner than if you're just trying to get a floor plan, for example, and you're just trying to capture the floor and move relatively quickly through the scan. So it can vary a lot, but in short, an entire residential home is absolutely within our wheelhouse. An entire office building is not, and that's kind of the best way to put it. And then lastly, the third thing to mention here is that while we are currently limited to 160 million points per scan, which, don't get me wrong, is a lot and is a very large scan to be capturing from a handheld device, We do expect that to be growing with future software updates in the near future. So stay tuned. We expect to start capturing larger and larger scenes. So thank you, Ali. Thank you, Billy, and thank you everyone for joining today and being so attendant throughout. We will be sure to send out a recording of this session, a copy of the presentation, and the data available to view in the IQ3 platform. So feel free to respond directly once that email goes through within the next day or two, and we'll be happy to answer any more questions that you think of.
Thanks, Chris. Thanks, Billy. It was a pleasure.
Have a great day.
Absolute pleasure. Thanks, guys.
Thank you. Bye-bye.
Have a great day, everyone.